with sine and cosine has not had anything added or subtracted here, right? There might be a number in front of x, but we haven't had any adding or subtracting. But today we're going to look at some of these things and what happens if there's a c value in there. And both sine and cosine, like we can write the same thing for cosine. Sine and cosine are interchangeable here in the fact of their translations. So I want to kind of show you where this formula comes from. And then once we have the formula, you don't have to stress so much about it. But we know that one cycle or one period, depending on what b is from 0 to 2 pi, right? Like that's our normal one period. Well, b and c are going to affect that. We know b changes the period. Well, c is going to affect where that period starts. It might not always start at 0 because we might shift it to the left or shift it to the right. So what we could do is we could take this part right here, and I could set it equal to 0, or I could set it equal to 2 pi, and I could solve it for x. And that's where this shift comes from. So I just want to do a little algebra here. If I wanted to solve this for x, do you agree I could add c over here? And that would be the same as saying bx equals c. And then I could divide by b, and I would get that x equals c over b. Right? Just doing a little algebra. I can do the same thing over here. If I add c, can I add 2 pi plus c, make it 2 pi c? No, I don't know what c is, so I would write that as bx equals, I'm going to write c plus 2 pi. And then I'm going to divide by b, and I'm going to divide each thing by b, just so it kind of matches up over there. And I get that x equals c over b plus 2 pi over b. 2 pi over b, does that ring a bell to you? That's the formula I gave you for the period, so it's not a coincidence that that shows up here. The c over b is the new part. We can tell what the shift is by doing c over b. So I just want to show you where that c over b comes from. I think I wrote it out here. So we can say that this graph has one cycle from c over b to c over b plus 2 pi over b. So we have always called these translations in other graphs. We always say like it's a horizontal shift. It shifts to the left. It shifts to the right. Just like the period and amplitude, we have a special name for it in trig. And in trig, we call this the phase shift. So we can say that if you have a number b and c in your problem, then your graph is going to shift to the left or shift to the right by c over b units. Here's the nice thing. I'm not going to make you graph by hand any phase shifts. I might give you a graph and give you an equation and make you match up which equation goes with which graph by using the phase shift, but you're not going to have to graph these by hand just because it does get a little bit harder. We are going to look at graphing on the graphing calculator eventually, and we'll graph the phase shifts. But you do need to be able to tell me what the phase shift is. That's kind of our big focus of today. Okay, so just like we have amplitude and period, phase shift is going to be kind of the third thing that you can give me when you're giving me these graphs. Can I go? Not go? Okay, so let's kind of summarize what we know here. Maybe. In summary, these are all the different letters or all the different numbers that could be put in for sine and cosine that could change our graph. Always, yes. They always use the number in front of sine and cosine as a, and it always stands for amplitude. The number in front of x is always labeled as b. When we write these out, a number added or subtracted is always labeled as c. I threw that D in there, and that D could be added to the front, or it could be added to the end, not in parentheses, which can also affect your graph. And notice I am only talking about when B is positive. I'm not throwing in any negatives in here, any reflections. Remember that a negative in a problem does mean a reflection. A negative out front means a reflection in the x-axis. Negative on the inside can mean a reflection in the y-axis. I didn't put D on here, but let's go ahead and say what D equals. Right? If you have a number added or subtracted outside of your function, it's always a vertical shift. Vertical shift. So if you have like a +7 out there, that means your whole graph's going to move up 7. It means it's not going to touch the x-axis. You have a -2 out there, that means it's going to move down 2. So that's just the vertical shift, the same vertical shift that we've always had. There's no special name for the vertical shift, but there is a special name for all the other ones. The amplitude, I hope that we're doing better with the amplitude now. Amplitude is always the absolute value of A, because it's distance. And the period is always what? 2 pi over B. And for the phase shift, we can say that the left and right endpoints of one cycle are bx minus c equals 0 and bx minus c equals 2 pi. And you're going to actually have to do some work to find what those new endpoints are. Let's see if I wrote this down here. We have a little picture for you. Kimberly, it's going to freak you out. My 5th hour class always complains that my notes are awful and dreadful, and I should make them more exciting. That's about as exciting as I get. We can also say it's C over B units left or right. So depending on how you want to say it, you can say it's shifted pi thirds to the left. What I think we need to focus on is this part. If I ask you for the endpoints of one period or one cycle, you can just set bx minus c equal to 0, bx minus c equal to 2 pi, and you can actually solve it, and we're going to look at some of those. I know, it's animated. So, on your homework today, you're not graphing on all of it. A lot of it you're just going to say, what's the amplitude, what's the period, what's the phase shift. So let's see if we can do one. So this is kind of a nice little summary of 4-4. Everything that you should really know about sine and cosine is kind of summarized on this one slide here. So let's look at this. Oh, look, I got more. Not that much. There's this whole list of things in the smartboard gallery that I could find and just copy and paste them over. I don't like that. So I'm pretty sure your homework says this exact same thing. Find the amplitude and period, the phase shift, and the vertical translation. Which means, do you know what all those numbers represent in that problem? Let's just go in order here. I'll let you write it down first. Sorry, I'm getting a little excited. You can definitely expect to see a question just like this on your test, where I ask you to list all these things out of, do you know what all these numbers represent? So, if I'm doing the amplitude, I'm going to take the absolute value of A, and what is A in this problem? 1/2, and the absolute value of 1/2 is just 1/2. What does that mean? That means my graph's going to actually kind of be smaller. Instead of going up to 1, it's only going to go up to 1/2 if I was going to graph this. My formula for the period, you got to know this, 2 pi over B, and which one is B in this problem? Pi, right? B is what's in front of X. So it's 2 pi over pi, which means in this case my period is just 2. So we're not going to graph this, but if we were going to graph this, think about the points you would pick on your x-axis. That was the big thing that most people wrote on their quiz from yesterday of what are you still having trouble with. Picking my points on the x-axis was a very common answer. This is one that we're not going to be picking radians in this one because pi is already in the problem. Like, think about, you don't necessarily have to write this down. But think about if I wrote 2 here for the end of my period, halfway between that would be just 1, and then 1/2, and then 3/2. Like, you don't necessarily have pi in your x-axis if your period doesn't have pi in it. And we haven't done that one yet. So I just wanted to throw that out there. So your x-axis might not have pi in it. Phase shift. This is the new one. If they ask you for the phase shift, you just have to know that formula. Just like 2 pi over b for the period, for the phase shift, you're going to give me the c over b. And if you think about how we wrote this out, this was bx minus c, right? So be careful on this. What is c in this problem? 1, because it's the bx minus c, right? So you do the opposite. Think about when we do our translations, doesn't minus always mean it's going to the right? So like if you had x minus 3 squared, remember that always means it's going to the right 3 because it's the opposite. So hopefully that will help you remember doing this. So if it was plus 1, you would take the negative because that would mean it's going to the left or backwards. So my c is actually positive 1 and my b is pi. We're not going to graph this because this would be really weird to graph, but this means our graph is shifting 1 over pi units to the right, which is going to really change it's still going to be the same shape, it's just going to change where it crosses the x-axis. But this is what you need to be able to do, c over b. What about the vertical translation? What letter am I looking for in that? D, which means a number added or subtracted outside of it. So like not in the parentheses, there's nothing out here, so what does that mean for my vertical translation? There's none. If you want to write 0, you can write 0. I'm just going to write none here. I'm like, we can say we did a good job or try again. There's sound effects for you too. Or try again. Don't you wish you had that on your test to tell you if you're right or wrong? Maybe not. All right, let's graph stuff. We still want to look at that. I'm not giving you any, and we can double check the homework today before you leave. You should not be graphing any by hand with a phase shift because I just feel like it's not that important and it's kind of crazy to do. I want you to be able to just graph period and amplitude, maybe reflection, vertical shift you graph. But you shouldn't have any. Notice there's no C value here, which means there's not going to be a phase shift. I would still start with my amplitude and my period. That's how I label my x and my y axis. Notice there's a negative in front of this. That's something to pay attention to. What does that mean is going to happen to my graph? It's going to flip, which means we can just make the XY chart, or every point that normally is up is going to be down on the bottom part of the y-axis. What's the amplitude of this? Yeah, there's just a negative 1 in front of that, but it's absolute value, which means has my graph stretched or shrunk any on this one? No, it's still the same. It's only going to go from -1 to 1. My period is going to be 2 pi over b. And what is b in this one? 2 pi. Which means my period is just 1. Which is going to tell me how to label my x-axis. If you don't do the period, then you don't know how to label your x-axis. So that's the big thing. And then we could also say, if you wanted to, you don't have to say this, but this negative means that it's going to reflect in the x-axis. So if you know what cosine normally looks like, it's going to flip over. We're going to graph two complete periods, which for me, if the negative's out front, it's always in the x-axis. If the negative was inside, then that's a y-axis. I don't think we see that very much, but technically that's how you know the difference. So my key points, this is the part that people said they're still struggling with. This is how you determine your key points. Whatever your period is where you're going to end your x-axis, or your first period. And no matter what that number is, whether it's 1, whether it's 8 pi, whether it's 22 over 7 pi, that would be a really weird one, every time you just take half of it and half of it again, and that gives you your one full period. So if I take half of 1, that's just 1/2, yes? And if I take half of a half, what's that? A fourth. And what would be halfway in between a half and 1? 3/4. Notice there's no pi in this. Why? Because pi's already in our problem. We can't have pi squared in our problem. So when we plug these numbers in, it's going to turn into those angles that we want. You're going to graph two full periods. If you want to graph all positive periods, we could go again. And what would I have to make my x-axis go out to? 2, because I would have to go one whole period again. But I like to do a positive and a negative. So well, it doesn't say, but I'm telling you on your homework today, you're going to graph two full periods. And on your test, you're going to always graph two full periods. So unless the directions say differently, you should get in the habit of always graphing two full periods. So I'm going to do the same thing over here, only it's negative. That's why I like to do a positive and a negative, because I already have these points, right? This is negative 1/2. This would be negative 1/4. Probably not equally spaced, but that's okay. Negative 3/4. Okay, that's terrible. Friendly was shaking her head. That's a little better. Thanks. And my y-axis, I only have to go to 1 and negative 1 because my amplitude is only 1. If you know those points, all you're doing now is plugging them into the function and getting the values. If you know what cosine looks like, you might not even have to do all this, but I feel like we haven't graphed cosine nearly as much as we've graphed sine. But I'm just going to pick these points: 0, 1/4, 1/2, 3/4, and 1. And this is the part that I was saying about the test yesterday. You have to know these values. You have to be able to plug 0 in here and say, oh, that's going to be negative cosine of 0. And you want to be able to tell me what cosine of 0 is without a whole lot of effort. Cosine is the x-coordinate, and at 0, what is the x-coordinate? 1, but there's a negative in front, so really it's negative 1. And if you go back and you look at cosine, every time cosine starts up at 1, every time that's going to happen, but because it's negative, we got to move it down to negative 1. I'm plugging it in for x, right? These are my x values. Yeah. I'm just plugging it in for x, but 2 pi times 0 is just 0, right? And if I plug 1/4 into x, I guess I can show some more work here. 2 pi times 1/4. What is 2 times 1/4? It's going to be 1/2 pi halves, so that's the same as saying negative cosine of pi halves. I hope if you've done all the homework, you've noticed that every time if you pick these key points, you get 0, then you get pi halves, then you get pi, then you get 3 pi halves. Those are those key points. And what is the cosine of pi halves? 0, negative, you can't have negative 0, so it's 0. When I plug in that next point, I should be going around. I went 0, I went pi halves. What angle should I get when I plug a half in? Pi, because every time that's what should be happening. And you can check. If you plug a half in there, a half times 2 pi, do you agree that's just going to be 1 pi? So you get negative cosine of pi. And what is the cosine of pi? But there's a negative in front of that, so negative of -1, see, it's going to switch. It's going to make it +1. That's what the negative does. And then what should be my next angle I get when I plug that next point in? It should always be 3 pi halves, which is why I say eventually you might not have to do all this work every time, because every time if you take your period and cut it in half, and cut it in half again, you're going to get those same points. You're going to get negative cosine of 3 pi halves. And what is the cosine of 3 pi halves? 0, -0, can't have. It's just 0. And you should end the same place that you start every time. When you where you start is where you end. That's how you complete one period, which means this should be the same value as this. And we can check. If you plug 1 in there, you get negative cosine of 2 pi. 2 pi is the same as 0, which is 1, but it's negative, which is -1. These same values show up over and over again, but you got to know the difference between cosine and sine. That's the big difference. When you graph cosine, it kind of looks like that, I don't know, like a big U shape, because it starts up and then goes down, but we're flipping it over. So we're going to start down here at -1, then we're going to go up to 0, then we're going to go up to 1, back down to 0, and we should always end where we started. And what's the great thing about cosine to do the negative side? Is cosine even or odd? Even, which means what happens over there on the other side of the y-axis? It's exactly the same. Those points are going to be exactly the same. So at -1/4, it's going to be at 0. And -1/2, I'm up here at 1. Back to 0. Back to -1. And when you graph two periods of cosine, it usually kind of looks like a W, but this one's upside down, so maybe it kind of looks like an M. Remember that we should be making smooth curves, not jagged edges. We need to turn this and say it's going back up because it's not going to go down anymore. Look at that lovely graph. Yes? No? Kind of feel good about graphing these? Maybe? I think maybe I have another one. Let's see. We do have right time to say. Oh, look at this one. You don't have to write all this down. I wrote this is from your homework, page 392, number 31. Like maybe just write this equation. And then if you want to open your book to page 392, you're welcome to. But you definitely don't have to write all that directions if you don't want to. But we want to start being able to look at these equations and determine what maybe we can figure out from this. So this one, they give you the equation y equals -3 cosine of 2x, and they give you a graph. It says give the amplitude and the period, which we could do just by looking at the equation. And then it says look at the graph to determine the window used, which means if you know the amplitude and if you know the period, you should be able to tell me what this ending value is, what this ending value is, what this value is, and what this value is. That's what they mean by the window. If they ask you to match the equation up with the graph, how do I know this is cosine and not sine? Look at where it starts. Sine always starts at 0. Cosine always starts up on the y-axis. But why does this one start down on the y-axis? Because they're negative. And so that's something to think about as you're doing these as well. So what would the amplitude of this be? Absolute value of A, the amplitude is just 3. The amplitude helps you determine the y-axis. So can you tell me what that y-axis is going by, or what the top number on that y-axis is? It's a little tricky here. A lot of people want to say 3, but do you agree that this has to be 3 because that's my top point on there? So if I'm giving my window actually goes up and down one more than that. So could I say my y-axis is -4 to 4? That's how the book always writes it, so that's how I'll write it. So if you know the amplitude, it's not so bad to give the y-axis. What about the period on this? The period is 2 pi over b. What is b in this one? 2. So do you agree that cosine is going to complete one period from 0 to pi? What does one period of cosine look like? Like I'm going to start down here, and how do I know when I've completed one period? When I get back down there, right? And so it's kind of making you go backwards a little bit. But that means I would start here, and I go up to 0, and up, and here, and then I would end right here, which tells me that right here has to be pi, because that's my period. Does that make sense? If the period were 7 pi, then I would know right there would have to be 7 pi, because that completes one cycle. Do I complete a whole nother cycle again? Yeah, do I go back up and then end back up, back again at that starting point? Which means, what is my end value on this graph? 2 pi. And it would be the same over here, but negative. Right? And so that's part of your homework today, is kind of working backwards and saying, what would the window have to be if they gave you a graph? And so that would be negative 2 pi to 2 pi. The book usually writes it x by y, so then like by negative 4 to 4. If you said x-axis, if you wrote it out much more wordy than that, that's not going to be wrong. You could say x-axis goes negative 2 pi to 2 pi, y-axis goes from negative 4 to 4, like that's the same thing. But that's kind of what we're looking for there. Questions about that? Do you feel like maybe it's making more sense now? Like I know it's a little crazy at first, but I hope that it's coming together a little bit. The plan tomorrow is to move on to 4-5 and talk about the other graphs. We haven't talked about what does tangent graphs look like, what does cotangent graphs look like. So I hope that by tomorrow we're feeling kind of good about this. I think this might be it. Oh my goodness, let's see. Oh, this is my last thing. You don't even have to write this down. Look at this cool little thing I got. In all my pictures, I found this too. This just kind of shows you what does A, B, and C do to these problems, right? A is the amplitude, B is the number in front of X, and C is this. So we already know A, right? If I keep making A bigger, it's just going to stretch my graph out. And if I make it really, I don't think it'll let it go to, it doesn't make it go to fractions. If it made it go to fractions, it would be better, but it doesn't. B changes your period, which means if I do this, and I keep changing B, oh my goodness, the period keeps actually getting smaller and smaller and smaller. I don't think I want to graph that, but it's kind of cool. Again, they don't give me fractions on this, but negative is going to do the exact same thing, just make it go the other way. So let's change that back to 1. Oh my gosh, I'm going the wrong way. That's a normal period. What about C? C is the phase shift, and I just want to show you that the phase shift is just going to kind of move that right or left. And so watch this curve as I change the phase shift. It's still the exact same curve. I'm just kind of sliding it to the left or sliding it to the right. Do you agree or disagree that if I slid it so much, I could actually end up in the exact same place that I started? Do you agree with that? What if I slid it so much, could I change a sine function to look like a cosine function? Yeah, because really sine and cosine are really similar. It just changes where they start and stop. And so I think it's hard to graph phase shifts because it's hard to get that x-axis right, but I want you to realize what's happening with that phase shift. I'm just kind of changing it from back and forth and back and forth, like a heart rate. Okay, you're not that impressed, but I thought it was cool. But that frowny face for you. 4-4 day 3. You're going to do 30, 33, and 34. And then I put these in parentheses. 44, 47, and 48. The directions say describe the transformation, blah, blah, blah. I want you to graph 2 complete periods of 44, 47, and 48. You're welcome to describe it. I don't care if you describe it or not. I say graph it. Find the amplitude, find the period. So make sure you kind of put those in parentheses. The one that's in parentheses. 44, 47, 48.
You're doing what? You're just finding...
You're going to graph 2 complete periots.
But then we'll do the possibility.
you're still going to do these, but you're going to follow those directions, right? So 44, 47, 48 have their own little directions with it, and this is on your assignment sheet. And then you're going to do the other ones. 54 and 55 are giving you some questions about phase shifts, asking which ones are the same, like I was just talking about. Like it says, match the two graphs that actually would look the same based on their phase shift. But I really think you're only graphing those three, 44, 47, 48.
You said you just want us to graph, not to describe.
Right, right. I'm fine with you not describing it. I would definitely list the amplitude and period because it helps you graph, but yeah, you don't have to describe stretch or shrink. And you actually have some time to work today, so if you have questions on test correction still, it'd be a great time to ask me, or if you have questions on other old homework, I'm going to help you with that, or just get started on this, so in case you get stuck, I can help you on that as well. But the first three are just like that last problem we did, where you're just going to say the window.